Еще раз. Так. All right, I think we have a deal. Okay. Hey, public.
Hey, Alex.
Can you hear me well, everyone? Nice. Yeah. How do I say it? Like a great Sunday to everyone. I think we haven't been in online for like a year or something, so not a lot of time. And today, me and public, not first time on in this company. So hey, public, how's it going?
Yeah, it's going quite good. We met some friends yesterday, and we were talking about the programming as well. Some of them work in some companies like JetBrains and others. So it was nice. It was great. How was yours?
Yeah, pretty calm today. It was yeah, it was exceptionally not doing sports. Like maybe it's a good thing to not do sports at Sundays. So yeah, it's a second in a strike already, a second in a row, and yeah, let's see how it goes. Yeah, beside that, yesterday was quite productive to be honest, and yeah, managed to do some interesting topics like one that we're gonna discuss today, for example, but also yeah, just doing with normal normal things like here and there. All right.
Yeah, sounds good. Sounds nice.
Yeah, we have a little bit limited time today, if I understand, about an hour, and we want to present, me and public want to present to our listeners, to our viewers today, quite a new material of ours. It's a new workshop that we're working together, and we gonna present it soon in a few conferences, hopefully. So today is actually like a dry run and a very dry run on this workshop. Hopefully you enjoy it, and if you like it or not, let us know in the comments or in any way you find it yeah, useful. Yeah. So what is a workshop today? Yeah, it's an unannounced, but I think it's. Still might be interesting for our followers. It's a workshop about how to build a RAG system in Node.js, in which we want to cover multiple, all different topics. Basically, the idea is to cover most of the paths that you need to do yourself to build a RAG system with Node.js. Yeah, things like a database we'll try to cover, which database you can use to build such a system, and yeah, what embeddings to use, do you want to use it, do you need to use embeddings, and do you need, what is chunking and what to do with that. Yeah, all things like that.
Yeah, before we continue, I wanted to mention that RAG stands for Retrieval-Augmented Generation. So just for our audience to understand.
Exactly. Thanks for that. Retrieval-Augmented Generation. Yes, we have prepared these slides. You can find them at our website, xtechnologydev/rag, a separate page. I think it's quite a good quality already of this page, so enjoy. If you find it useful, again, let us know. Yeah, a little bit about prerequisites. Hopefully you can learn yourself. So we have a separate repository where you can find examples from this workshop and run them yourself. Here's a plan. It sounds actually like I don't know how we're gonna do with it today, but hopefully in an hour we'll cover some big chunk of it. Yeah, as you can see, it's covering overall idea of RAGs, then doing some practices with a Hello World exercise. So first try with not necessarily a RAG system, but just LLMs. And then we can explore.
One second, Alex, please. Can you also share the link in the chat, maybe?
Yeah, that's a good idea. Let's go. Yes. Just did. Yeah. Nice.
And now I need to find the chat. Right, yeah.
It should be there, right?
Is it the chat here or in the YouTube?
In YouTube, yeah.
Okay. Can you also share the link here so I can open the one in YouTube?
Oh, someone asking about it? Or?
Me, because I don't have a link and I don't
Yeah,
see this
for
screen.
sure. Does this work, public? Send you a link in YouTube, yeah.
Okay. Yeah. Can you also share? Yeah, thanks.
Awesome. Nice. Yeah, meantime, hopefully you had a chance to look at the agenda today, so let's not reread it. We're gonna explore it anyways. And I think we're also gonna skip introduction part about me and public, so hopefully it's not needed. If you want to know more about it, just look into past materials of ours and see the links that are attached to the video as well, and in the workshop itself. First of all, a few words about what's the idea behind this workshop, like what we want to achieve with that, and personally, like what's our experience with building such systems like RAG. The main goal, I think, is to explore the cycle of a RAG system, things that need to be done to build such a system, architecture and components of which RAG contains or consists of. We also want to see it in action, so we want to actually try it with an environment that we find the most useful. not most useful. Yeah, I'm just doing some things in parallel. We find it practical to use ourselves, and that's why it's just easy for us to play with. So I'm talking about Node.js, as you can see. So basically, the idea of the overall workshop was to overview various scenarios, various technologies, various components of RAG system, and then also, of course, to give some summary out of that. And for that, we want to compare really different models, different hyperparameters of RAG system. But I think for today, we're just gonna focus on one way of doing that, and we're gonna mention other features and other things that you can develop or attach yourself to your RAG system. We're looking forward to any feedback that will help us to evaluate this workshop further. I think last thing from my side before I can start, and maybe public will add something as well, that I haven't. I believe I have built some RAG systems in my career, but I think at the point when I was doing that, it was not yet known as RAG systems, and also LLM, I think, didn't exist there. But I have some understanding of components on practical level and how to use them in real project. So I'm going to talk a little bit about it during the workshop, and public, anything to add before we kick off the whole theory and part and the rest?
No, not really. Sounds good. Let's start the kick LLM and the RAG.
Yeah, exactly. Yeah, I was thinking to add like a Ragu logo somewhere. I haven't seen any technology with RAG that uses this logo. I think we should really do that. Maybe I will just generate a Ragu image with AI and put it to this YouTube video or something like that. Okay. Good enough, let's say. So we can start. The idea is to give some basic terms that we're gonna use today to give you indeed the idea what we're working on. Yeah, things like what is RAG. That's exactly next slide here. Yes, but before that, it's about using some generative AI, and what is a generative AI? It's you can think of machine learning, artificial intelligence that produces content, and because we we kind of consuming, we kind of producing content for humans. That's why it should be in human-based format. And in our workshop, we focus on text, of producing text of the content, but it also can be applicable to other types and other formats of content, such as video and audio. But I think for that you will need to use different other models, not the ones that are commonly used for text content. Things like OpenAI, ChatGPT. Those are those you can keep in mind when you're looking at what we're gonna use. Of course, we're gonna use LLM because this is a part of RAG, and hopefully we're gonna see that today. LLMs is kind of large LLMs, and LLMs is a language model, which basically the idea of with these models is to predict content based on previous content. Like you give it some input, and it based on what it has learned before, the model has been pre-trained, how the words compose into human readable text. Its idea is in a nutshell to predict the next text content or next word in a sentence if you're producing that. You can use these models for different tasks, for summarization, for answering some questions. You can think of chatbot scenario, and you can also do some research, let's say, in the bank of documents that you have, and that's one of the tasks that we're gonna deal with today. For LLMs, I think we kind of in the last 2 years, plus or minus, developers got in touch with using LLMs as an API as well, and for us, we also gonna use it as a black box. So we don't want to explore what is underneath the LLM, but what we want from it in a nutshell is just to give it some input, and it will give it some output, and we want to use it as an API in our tasks. Finally, the Retrieval-Augmented Generation. I was thinking about how what is the right word for that, and there are many actually words that I think can be used in the context of RAG. Like what it is, what is it? Is it? Yeah, of course. I mean, don't mean the abbreviation itself, but is it like a theory model? Is it a system? Is it a software? You can, basically what part of these abstractions is RAG. And I think indeed there are different words. You can think of it as a system, but I like to think about it as a task, like in different scenarios, in different organizations. You most likely need a task where you have some knowledge base and you want to work with it, with this knowledge base somehow. So the idea of RAG is to know about this knowledge base and to give you interface, and the best if the interface is applicable for your needs, so to interact with human, let's say, so in text format, and then you can retrieve different documents and answer the questions that you have for this knowledge base system. Maybe it's also a little bit abstract, but it actually is quite an easy system if you think of it like in components that are black boxes inside, like LLMs. Basically, what you have is a knowledge base, so a database of documents that are owned by some organization. There is a LLM in between, and what you want to do is to get a query from a user, and then to find applicable documents from a knowledge base that can help to this query. And then you pass all of this together. You combine this somehow, the information about retrieved documents, or the documents themselves, and the prompt that the user has given before. And you make a prompt out of it, and you push it to LLM as a black box. And the black box, because of its because its natural needs, and not needs but structure, it will predict the output that needs to be done for this query, right? So how it will be answering the initial prompt with a given document's context, and that's an idea. So to empower LLM with a relevant documentation that is, let's say, private to your organization, or can be private to your organization. Yeah, so it's a RAG. Retrieval is a search in this notation, and generation is a part of that LLM is responsible for. The most common scenarios, as you imagine, is chatting with user. It's the first one, like you pass the whole knowledge base to this RAG system to learn about, and then you expect the users just ping some questions, right? Just drop some questions, and if the system finds relevant documents, it passes it to LLM and produces an answer that will be, in a nutshell, based on the document, based on the context of your documents. So it will be truth in your particular case, but also with LLM help, it will be readable for humans.
Hopefully, truth.
Yeah, hopefully we're gonna show it too. Nice. Yeah, and this is like a pseudocode that just gives these three functions. So RAG is a function here. First, we search our database of documents with some subsystem, search subsystem. Then we get results out of this, and we make prompt out of these results together with the initial query, and provide it all as an input to LLM. And then what is returned, just given to a user. It's very high level, of course, and there are more steps in between. But I think it's just easier to imagine it like that, and then these different layers we can explore and discuss later on during the workshop. Yeah, I have maybe a few questions for you, Pavlik, because you're my audience today. So do you have an example, so an ideas why would we need a RAG system?
Yeah, but it's actually just comes from what you have explained. That might be some personal data store of the knowledge that you have within your organization, but it might be even like publicly available, but just a big knowledge. Let's say one of the examples that I always have in mind is a book. Like, let's say it's a book about the Harry Potter. And like obviously LLM did parse a book about the Harry Potter, and sometimes it even like most probably be able or will be able to provide answers about this, but it is not always like this. And in order to help any LLM to give an answer about the book, we need to actually pass the book to it. So please like read the book and give an answer based on the book. But the book is too big for the context window, so that's why we need like some kind of elaborate search on it. And that's where like your function like actually describes beautifully what's this about, because you first of all we need to have some kind of search to be able to get the most relevant parts based on what we think that LLM will be able to give an answer. Then we make a prompt to actually give this information to LLM as the context, and different LLMs get it as in a different way. And then we ask LLM with this information. So yeah, the book, the organization, and maybe like I think everything that is required some kind of the knowledge base that can be represented and provided as the RAG to LLM to improve the results.
Yeah, precisely true. Yeah, exactly. The specific knowledge is number one top use case for that. Yeah, I have here other two things: reduce hallucinations and control system costs. I think also pretty straightforward, right? Like when we let's say ask LLM about some general knowledge, it just it's just based on everything, right? So it's gonna be very common answer. But if you provided some specific context in which you want to limit it, you have like a chance to get a better answer out of it for a concrete question, for a concrete thing that you want to know about the knowledge base. And the control system costs is about that part that usage of this context window, for example. Like it's also related to the next question: why can't we just put all the context in LLM and ask it about? We can do that, but it has some drawbacks like cost. It also will be working on it probably some time. Some more time than the RAG system itself. Because of the other things like noise as well. So it should be more concrete. The answers should be more concrete, and that's probably what a user needs in this use case.
By noise, you mean the laptop, right? If Intel chip is working, it's very noisy.
Yeah, that's what I meant. Yeah. Thanks, Public. Right. So what would we need to build such a system? In here, I just sort of repeat the same steps that are already in here. Let's think, but maybe in terms of technical systems, we will need a backend which runs this and combines this logic together. We need a search system, and that can be only database layer, but in most cases you still need to wrap it up somehow and build business logic around it. And you need to connect your LLM somehow. Like what LLM? It's a good question, and we're gonna use one of possible scenarios today, but you can think of the most popular scenario. Just make your OpenAI account, and you can go and use the API from there. Finally, in this section, we just briefly introduce LangChain. So basically, just to want to say that most of our examples today are gonna be using LangChain. It's an open source library primarily for Python, but also very extended. I don't know how to say it better, for JavaScript world. So you can use the library in Node.js, and it's quite rich in API as well. I think it's between these environments and other implementations of LangChain, for example, for Java, they all not 100% have the same interface, but the idea is still there to have some chains. So this is what LangChain about. They provide an API in way of chains, and this chain is basically some query to LLM that is programmatically specified in your source code. And basically then you combine these chains to make the desired flow with using LLM in your application. And that's in a very short way describe what LangChain is. But basically you can connect to any LLM through it. It has support to databases as well, so you can build these kind of systems easier than you do it from scratch. It has also logic between, like how to split your documents, things that we're gonna discuss today as well. Nice. So I think with that, I will ask Public, what we need actually to run most of the examples today, and what is the first example that we can see.
Yeah, sure, thanks. So as I actually mentioned in the what do we need to build the RAG, that's like in the setup is the technologies that we're going to use. So because hopefully, I don't know, not hopefully, but most probably most of us are like a JavaScript programmers, hopefully not though. And but then Node.js is a tool for us to go. Then we have, as Alex mentioned, the most default thing to do is an OpenAI with API. But OpenAI API, even though it's one of the best, probably one of the best in the market, it's also costly. So like our workshop essentially is built in such a way that you can use two options, and it's either OpenAI API and then you will have a better results, or you can also use Ollama. This is the system that you can install on your local environment. And then this system will allow you to use LLMs locally. Yes, the models will be not as powerful as OpenAI, but that will be absolutely perfectly fine for our workshop. And this is actually would be the recommended way, because you will be able to experiment more with different models, and also you will be able to learn how to use Ollama for the local development without paying things. As also Alex mentioned, LangChain and NPM. LangChain we also chose for like demonstration how easy then to switch from Ollama to OpenAI with the power of LangChain, because it actually abstracts a lot of the things. We'll be able to learn. Our first practical example will be the most, I don't know, the most obvious one. We are going to make a call to LLM. And in this example, we provide Ollama. We just create Ollama and tell to Ollama that it needs to send a message which has a content, what is the Retrieval-Augmented Generation. So that's what we are going to do.
You can share a screen, right?
I can share the screen.
Yeah, let's see. Yeah.
I can share the screen, and that is my entire screen.
That's amazing how it all works. It probably will be slowing down with the layers of what we share in.
It's a real like conception in real life. How many things we share inside each other.
Yes, exactly.
But okay. So first of all, we have the files prepared for you. They are all on X Technology Rack workshop. Just to be sure, I'm going to share the link as well. Hopefully in the chat on the YouTube. So then in this workshop, I have like the code locally. You can also check out this code. And then we have SRC folder and the practical examples. And this is the first practical example that we are going to do. And let's take a look at the code there. I will also enlarge everything that I have just for better viewing. Increase font size.
Probably you shared so the window, not the entire screen, because we see the GitHub page.
Oh, 1 second. Then yes, let me try it again. Share window, entire screen. You're right. I shared the window accidentally. Yeah. So yeah, here an idea. We have our first call. First call is extremely easy. We are going to first of all install Ollama package, and then Ollama package is identical to what we have, to what we do in the example code. So we just do a chat. To install Ollama package, we are going to a different website, which is surprisingly Ollama dot something. It's Ollama install. Let's just start this there. Ollama.com, and it's download. I'm going to share this link again. So this is like very simple application. You just install this application, very simple, and then you run this application. I have it running locally. That's the icon of it. You can see it's very similar to what we have on what they have on the website. And then this, after you install it, you will be able to install the model locally. So this is the tiny llama model from the Facebook, but it doesn't matter from what it is exactly. You just do Ollama locally and then pool, and then the name of the model, and then you press enter, and now it downloads the model. I I actually doubt that I do have the model locally, otherwise it would not download it. And this model is around like 800 megabytes, something like this. So it is almost downloaded. We are happily enjoying our fast internet here. Oh, something else is starting. But it will download the model soon.
Eventually, yes. Oh, nice.
Eventually, yes. So that happened finally. And now we can execute our example and enjoy what would it say about retrieval-augmented generation. Let's test Alex's knowledge and compare it with the output of the model, or the model knowledge as well. So for this, we are doing Node, src, practical examples, one, first call, and then llama. Q. It will just show the response of it in the console. And we can see that the retrieval-augmented generation is a type of general model augmenting information words, generate not just the context of the existing text for the complex tasks and possible traditional NLP methods alone. So as we can see, the model failed at the test completely. So it did generate it did understand that we want the information about the retrieval augmented generation, but it found it somewhere in NLP tasks, even though the context of the answer was more or less close. And sometimes it even mentioned that like neural networks and such, but still in NLP methods alone. So, but this is the, like, in fact, because we used the tiny llama 1.b model, we of course always can go to the website here and search for the better model. Yeah, like the better model most probably will be like a bigger size. But I would recommend somewhere in the background, download and start using something like Llama 3.3, 3.2, or 3.1. So this model, like, it's probably a little bit bigger. I think it's maybe several gigabytes. But this model will be, yeah, like it has a very good performance, and we will be able, even probably for this exercise, see the correct answer to the question. But okay, so at least we see that the key point of this exercise is to make a call to a system, and we see that like making the calls is extremely easy. We will have a little bit more advanced example. So this one is when we just made the call, got the response, and we output the response. But when we work with the OpenAI, we can actually work in the chat-like manner. So we ask the question sometimes, or like ChatGPT gives that's basically chat is in the name. It gives us an answer, and then we are able to actually correct the question or correct the answer. So let's try to do this as well. And this is from the simple chat llama file, and the code here is extremely simple as well. Like, it does exactly the same as we did in the previous example, except that in the first thing we create an interface from the read line, and we will be able to read directly from the terminal what are the input. And then we pass this input with the exact same command, llama chat, to our llama model, which is even like the model is the same. And then we share the output of it. The interesting part is that the messages, it is an array. So in exact same way in the previous example, we just combine all the messages to this array, and then we provide this context to our LLM. So let's copy the question just to be able, we can test on it, and then do very similar stuff. Node, src, practical examples, to simple chat, or llama, go. All right, so our message. Let's start with the same. Retrieval-Augmented Generation. Why it is useful. All right. So there is a little bit of time when our LLM is thinking about the stuff, like human being. So it is output on conventional language translation agents. Okay. No. Can you provide an example in regard to large language models? Let's see what it is going to reply on this one. Here is example of large language model augmentation. Company treatment produces medical devices for diagnosis and treatment. Okay, so this LLM, even sometimes it does understand what we want from it, from the context, but it's still the quality of this model, because it's like only 800 megabytes, it's by far not the same as the bigger, like its bigger relatives. But at least we can see that it does understand something from the question still, and it keeps the whole context. All right, thank you very much.
Nice.
And now the final example is the same, but with the length chain. And with the length chain, we essentially, yeah, you can see it does exactly the same. We create first the chat, provide the model there, and then we explain where it's where we store the context, and then we see whether it's what is the output after several questions. So you can see that here the interface is slightly different. So we don't say chat with the number of messages. We actually just say call with the input, and but other than that, it's quite the same. And let's try this. MP node src. Practical examples, 3 length chain llama, and then what is rack, and then why is it useful for document retrieval. It's actually just have 2 answers, and you can see here,
Llama is not hasn't started, or
no, that's I think I'm running it on a different URL maybe, but llama should be there. Yeah, it does seem that I surprisingly have it on a different address, but then this can be removed. So here, like in a very similar way, yeah, now it is it generates a very similar nonsense, but and also multiple times, because it actually has all the content saved before. So yeah, those are practical examples, some basic foundations that we are going to use for our workshop later.
nice.
Thanks, Alex. Back to you.
Yes. Yeah, nice. And yeah, it's cool to try our setup as well. Like a first time, I think it goes really smooth. Yeah, so basically, sorry, next step is to provide you some idea what we're trying to build, right? Like we want to have some knowledge base, we said. So what is this knowledge base? And here is a just nice video on how documents go through the RAG process and what's happening there. Yeah, I just found it on one of the referenced articles in this workshop, and just put it for fun here. Anyways, the use case that we exploring is it's not something extraordinary. What we want to do is to analyze a pack of articles written in specific area, and we are interested in Node.js, so we actually got a collection of the RSS feeds, of different RSS feeds, and the blog post from Medium, blog post from dev.to, and different newsletters. So we got it through the last year. I think it was from 2024, and then basically we analyzed these articles, we put it to this RAG system, and we want to get some understanding on what was important in these articles, what was discussed the most. So we are interested basically to explore all the articles that our feed, different feeds have been writing, and that the community was reading through the last year. So yeah, we want to first collect and process this news somehow. Then we want to store them in database, right? And then we want to send different queries, and these queries will be retrieving relevant information from our database and then providing or producing the answer together with the context of article. Here is a nice representation that a nice application atlas, which I pushed all the same data from articles, and you see it's a nice tool that lets you explore your data set a little bit. It's pre-clusterized by some semantical function, but yeah, it's nice to see, like it's just nice to see visual representation of your data there. And if it was some let's say not human readable content, it would be probably much more explainable. Like you can see the data, and then you can see there are some outliers, and why there are some outliers. It's less useful to explore it like that with just a text data set. But still, it's really nice that they are clusterized. Yeah, in here I wanted to explain how we did get these all articles. You can see this task as a traditional web scraping method, but in this case it's a little bit easier because RSS feeds, they are open to be scraped. Actually, they are written to be scraped, so we can just, by knowing different URLs, we can digest let's say last 10 posts from each feed source, and then we store them in some file locally. Actually, you can find articles in the attached repository as well, and build your RAG on top of that if you want. If you're interested in other resources, you probably want to scrape web information for your own purposes. So first of all, make sure that this is aligned with privacy and policy of the sources that you're using. And second of all, you will find still a lot of challenges during this task. Like if you want to do it yourself, then you need to build a backend which is gonna be doing fetch requests, HTTP requests to these resources, and doing it parallel if you want to make it faster and make it error prone as well. So there are lots of challenges. For our use case, we just use the external service that with which one you can just attach different URLs, and then they will be scrapped for you automatically. Beside that, there are other challenges as well, like the quality of text, because as you can imagine, if it's some magazine, it follows some specific type of writing an article, so it might have some noise inside. You can think of some marketing titles or marketing sentences in the beginning or in the end of the newspaper. So what I'm trying to explain here, there are different other problems that you might experience yourself if you build in such a system, and for that you also need to find some answers, like how to prepare this data set. For example, you want to apply some noise cleaning algorithms, we implemented one of them in our repository as well, but that's out of scope for today. So what I'm trying to say is that before you making a system that will be working in production for you and your organization, you might want to know what kind of data you will be working with. It can mean that, for example, your dataset contains PDF files, so you will need to parse PDF files upfront, and then you also can use LLM for that. I think OpenAI now has integration with also PDF. It can do PDF parsing for you very nicely, but again, it's costly. So yeah, you can prepare a system which will be parsing it outside of LLM as well. So all depends on what kind of data that you're gonna be using. You can also think of other format that you want to parse image to text, and then work with text as a data set. And also it matters what will be the queries, what your users will be asking, because if there are, let's say, most often queries, maybe it makes sense to think about how to cache them, so you don't actually do queries both to database and also to LLM to produce the same kind of answers, but instead you want to use some cache in between, cache layers that will help you to save some time and money, which is kind of the same. But anyways, so this is the first thing we did. We collected some articles. Next thing, what we want to do with it, we want to store it in database. So after that, we're gonna be doing some queries to database. So, but how we gonna do queries, and how we gonna store them, and how we gonna search them? This is a part where we start talking about database. And the main idea for these kind of systems, for RAG systems, is to split documents on ahead of time. We can say not ahead of time compilation, but when you're preparing your data set, you actually gonna be splitting your documents into smaller chunks. So this process is called chunking in this system. And the idea is that you can think of documents that are really big, like maybe they even get into context of like a context window of LLM, but it will be containing so much irrelevant data for the original question that the user might ask about this document. So most of the material inside this document will be irrelevant, and eventually will make a lot of noise to the original answer. So that's, I think, the main idea why you want to use chunking. Basically, you want to not the whole document answering one specific question about what user want to know, but you want to just know with the fragment of text that describes this answer, that contains the answer, and it would be great just to use this fragment to produce the real answer from LLM. So that's the idea of chunking, and there are some benefits of using it. Reducing noise is kind of idea and the goal, but also reducing noise, it helps you with a cost usage of LLM. Like it's gonna be less context passed to LLM, and therefore you can make less queries, let's say, and they will be also faster in most cases. So those considerations, I think, they are all around in this RAG pipeline. Okay, so to chunk or not to chunk, we can also think of a system that doesn't chunk documents. You just pass them one by one. Like, let's say you retrieved first a similar document or relevant document, you pass it all to LLM, produce something to a user. So that will be also RAG, but you can then compare the results and see if that would make sense to do it so or not. In most approaches, the documents are splitted, and then the question is, how do we split documents? And there are different answers, different ways of doing that. The most simple and the most straightforward approach is to basically split it by limit. You just say, I want to specify 200 characters, so that's where my chunks are, and then your text is divided into these chunks, and when the query is sent to a system, basically the chunks will go one by one until we found something relevant to original query. But you can also imagine the situation when your chunk contains first chunk and the second chunk that goes right after. They both contain useful information about the query, but for the reason of, because chunk is just strictly split, you lose some piece of information either in the first one or in the second one if this chunk is retrieved or not retrieved. That's why you want to actually have also some running window between them, and that would give you more chances that your relevant data is inside the chunks that has found to be useful. I think the idea of running window is also not new, so most likely it's you could see that in other systems as well. There are nice representations online of splitting a document, so it gives you the practical idea of how the chunks might look like when they intersect, if you increase the window, things like that. And you can also check which kind of chunker strategy you want to use in your particular case. So we talked about splitting by character, right? That one will be using just these params, size and overlap. But in most cases, that won't be enough, because this is the drawback is that this method doesn't use the semantic of text. Text semantic, but yeah, here we go. We can actually do better. So how do we do better? We know some special symbols where our text uses, right? Like for example, sentences. Yeah, those are divided by dot, and there are also paragraphs. So most likely one paragraph is about one thing, second paragraph about second thing. Well, not necessarily about second thing at all. It can also be about the first thing, but it doesn't contain the third thing. That's maybe the better approach to say it. So that's why other strategies, they also take into account how the text is structured and they use special characters to split it like that. But again, this is easy, so this is fast as well and cheap in that sense, so why not to try this one. There are other splitters that are even more complicated and make it a better performance in some cases, and those basically will be using understanding of a semantic of the text. So how they do that? They can be either some NLP solution that brings the structure of sentences of the whole text and retrieves some propositions, extract propositions from text, so just facts inside the text, and then you store the chunks of data as these facts that you recognize from your NLP query. You can also use some kind of agentic chunking. So in this case, you literally provide the context of a document to LLM and ask it to give you some chunks of data. So you can think of the most the examples are actually quite nice. Like if it's a user chat bot system. Then you can think of generating hypothetical questions that your users will gonna be asking about your knowledge base, and then you can store the questions that users might ask, and then actually your search function will be much more precise, because it basically the user will be asking something really relevant to what you already generated, and then the chances that you retrieve the correct chunk or correct document is higher, theoretically again. So yeah, there are different approaches to that. You can also just ask LLM to summarize some piece of text, like the whole article. What are the main libraries that this article is about, if you're talking about our use case. So yeah, that can be also useful. And in our case, I think we're gonna show I don't know. Let's ask public what we're gonna show.
And we are going to show exactly what you described, different chunk or splitters, and how they look like in the according to the length chain, and what are the nice things about them. So yeah, let me just now share the screen. Now I'm going to share right from the beginning the entire window. I hope that will help. Let me know when you see this.
Yeah, well, great.
Yeah. So for this, we have a special file, which is document splitter. So in this file, basically exactly what you described, we have the character text splitter, which splits just by the number of characters without any consideration of the structure of it. And the recursive character text splitter is a little bit more advanced. It actually, according to the LangChain documentation, it goes like this. It tries first to fit several paragraphs inside one chunk. If the part of the paragraph does not fit the chunk, it goes to the sentence. If it's still not the case, then it goes to the word. And that's why the information that will be eventually in the chunks will have a little bit more meaning rather than just like a random characters somewhere in the middle of the sentence. Also, like nice thing about recursive character text splitter, it also can work actually with some other documents, like other type of the documents, for example, markdowns. So you can literally specify as the part of the parameter for this recursive text splitter separators. And in the separators, you can say that in your markdown, the dash means like a new item in the list, star or 2 stars mean the title, etc., etc. So this is very nice feature, but we don't have markdowns. Our JSON documents are just like text. So we don't really need the separators. And then we go by the chunk size 500 by default, and the overlap is 50. As you can see, there is like some pre-built implementations for a little bit more semantic splitting of the text. It goes by paragraphs and by sentences, but because this split by tokens actually, this split by tokens uses a recursive character text splitter, and this recursive character text splitter actually does think about the paragraphs and the sentences. We don't really need to use those functions, but they're just here for the sake of a demonstration. And now we can, this function, I hope, is exported. Yes, it does. So we have, let's say, a dev file. In the dev file, we can import something from somewhere and just see it's in action. And then do we have we need to pass a document here. So let's say we can just execute this function. And then for the document, we are going to use the same as from your example, Alex. So where can I find this link to them?
Yeah, I was in our website, xtechnology.org, right?
Did you share it in
here, right? This one.
The one that splits the text with the colors.
Got it. Yeah. Yeah, we'll share it in the chat in a sec. Yeah.
Teams, YouTube, okay, yes, chunk fields. Okay, perfect. So we're going to copy the text right from here and see how does it split the chunks, whether it's similar or not. So here we just pass our text, really long text, and then we say, let's do recursive splitter. Let's increase the chunk size to, let's say, 300. and the chunk overlap is 0. So here then chunk substring split by tokens. So it uses the default params, and let's just change a little bit the default params to what we have here, and it would be 300 and 0. 300 and 0. Now we can use, and this dev.js document, I think it is a script actually, so we can actually run npm run dev. So it did split into 15 chunks by tokens. Is this correct? Number of chunks 20. Okay, that's interesting. Then it splits into 10 paragraphs and 37 sentences, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The paragraphs are correct, and the sentences most probably are also correct. And then let's check.
Maybe there were some special symbols when you copied it comparing to original text or something like that?
No, not really. Okay, does it have one? Yeah. All right. It's actually interesting, and apparently the recursive yeah, the document length is the same. So it just means that recursive text splitter works differently in the
Python and JavaScript.
Yeah, in the length chain. And just to be sure, we can also console log the chunks, sample chunks split by tokens, and then token chunks. Let's just output them in the very end. And then compare it a little bit. One of the most, yes, and it ends with, then it goes teachers, and then and you go teachers, and you go, then it goes out of business, and then it goes to VC. Oh, it's actually quite the same. All right, so I'm not going into details right now, what is the exact difference between those chunks, but at least we can see that they're similar to each other. Thanks, Alex, back to you.
Yeah, cool. Yeah, actually, let's see. We have, I think it's quite, we planned 1 hour for this first session, so it might be a good idea to, let's see. Oh yeah, I got it. Now I have you public and in the correct size on my screen as well. So maybe it's a good idea to stop in here, and maybe we can also try and do the second part somewhere during the next week, or whenever we have time during the next weeks, let's say. For now, I think we just want to wrap it up, and yeah, see you soon for the next part where we talk about embeddings and how to actually retrieve the documents and then generate some context about this document. See you guys.
Yeah, thank you guys for tuning in. See you.